Chapter 1.11.11 Cluster Autoscaling. Summary. Cluster autoscaling in Kubernetes helps manage node resources to run workload and system pods efficiently. Two main scaling methods are horizontal, adjusting the number of nodes, and vertical, altering the capacity of nodes. Tools like Cluster Autoscaler and Karpenter enable automated scaling, enhancing resource management and cost efficiency through integration with cloud providers. Automatic node management is further optimized by tools such as the Descheduler and Cluster Proportional Autoscaler, which help consolidate workloads based on cluster size. This includes both horizontal adjustments, adding, removing nodes, and vertical adjustments, changing resource allocations. Integrations with cloud services facilitate efficient scaling. Cluster Autoscaling. Kubernetes uses nodes in a cluster to host pods, accommodating both workload pods and Kubernetes components. Node autoscaling allows for resource adjustment. Adjustments can involve increasing the number of nodes, horizontal scaling, or boosting existing node capacity. Vertical scaling. Kubernetes also supports complex scalings like multidimensional scaling. A cluster's efficiency depends on managing resources for pods in the Kubernetes system. Node autoscaling adjusts this capacity, either by adding more nodes, known as horizontal scaling, or enhancing existing nodes' capacity, termed vertical scaling. Kubernetes offers advanced options for scaling nodes in multiple dimensions. Kubernetes clusters must provide enough nodes to run workload and system pods. Node autoscaling can increase node numbers, horizontal scaling, or boost capacity of existing ones, vertical scaling, ensuring adaptability. Beyond simple scaling, Kubernetes can automatically adjust in complex ways for optimal node utilization. Manual node management. The text discusses two approaches to managing node capacity in a cluster: manually setting a fixed number of nodes or automating the management of resource allocations like CPU and memory. While manual management allows for manual setup and automated provisioning, the next step for efficiency is fully automating node capacity management, ensuring optimal resource distribution without manual intervention. Automatic horizontal scaling. Cluster Autoscaler helps automatically manage node scaling in a cluster. It's compatible with cloud providers or Kubernetes Cluster API for node management. It adds nodes for unschedulable pods and removes empty nodes. The autoscaler can integrate with various cloud providers. A README document provides details on available cloud provider integrations for the autoscaler. Cost-aware multidimensional scaling. Karpenter manages cloud nodes using plugins for cost optimization. It quickly launches the necessary compute resources for Kubernetes clusters. Designed for easy cloud provisioning with API-driven server management. Karpenter shuts down existing nodes after provisioning larger replacements. Integrates with AWS and Azure, not maintained by Kubernetes authors. Related components. Descheduler optimizes resource use by moving pods to fewer nodes, aiding automatic scale down when there's extra capacity in the cluster. The Cluster Proportional Autoscaler adjusts workload replicas based on cluster size, nodes and cores, ensuring system components like cluster DNS are proportionally scaled. For workloads requiring constant replica counts, the Cluster Proportional Vertical Autoscaler adjusts resource requests according to cluster size. This tool is currently in beta.